because I like to have as much merch as possible.
Hey guys, I'm Bryce. I'm the VP internal. So I do a lot of the internal affairs of the team. Yeah, so I'm a fourth year mechanical engineer. I have a CS minor and I try to finish it out this year. I was a former IREC Avionics and Recovery lead for 2 years. In a past thing, I was the SL design and manufacturing lead. Yeah. Hold on, Joel, can you give her access to unmute? I didn't know that we had that.
Yeah, sorry, I had to change the setting. You should be able to unmute yourself.
Yeah, you're good. Can you guys hear me?
Yes.
Yeah. Is the camera pointing towards my face? I cannot see it. Okay. So hey, my name's Ireland. I'm the treasurer. I'm a fourth year mechanical and aerospace engineering major. I was the treasurer last year and was a former member of the testing sub team. I had a cool internship at Blue this past year since January. So if anyone wants to talk to me about that, feel free to reach out. I'm also doing the dynamics TA position, and I'm involved in undergraduate research. If anyone wants to talk about that as well, feel free to reach out.
Hi, I'm Jason. I'm one of the safety officers on the team. I'm a third year dual mechanical and aerospace major. I also got my L1 cert this past summer, and I'm also a DMLTA. So Raymond couldn't make it to this meeting, but he just asked me to introduce him. He's also another safety officer. And yeah.
All right. Hi, everyone. My name is Megan. I am the project manager for the NASA SL project that we do on the team each year. So a little bit about me first. I am a third year aerospace engineering major with minor in electrical engineering. I was formerly the testing lead for NASA SL. I also have an L1 cert, which you'll learn a little bit more of what that means if you don't know what it means yet, so don't worry about that. I was a Lockheed Martin Aeronautics intern this past summer, and I'm also an engineering ambassador in a DMLTA. So if I have any questions about the College of Engineering or majors or anything like that, I can talk to you about that sort of thing. But more importantly, if you have questions about NASA SL, I'm the person you can talk to about that. So go to the next slide. So now I'll tell you a little bit about what NASA Student Launch is. So this is just a little bit quick overview, some of the more like administrative stuff of what it is. It's a year-long competition every year that's created by the Office of STEM Engagement at NASA Marshall Space Flight Center. So the competition is different every year, so the requirements will vary. So we do it each year, and each year it's a different project. It does require a proposal to be accepted into the competition and actually compete. That is due on September 20th. So we're in the middle of that process right now. So if y'all are ready to just like dive in and start working right away, then please talk to me or talk to the sub-team leads, because we are already working. After acceptance, it consists of 4 reports that are 4 scheduled reports that have to be submitted to NASA. And also we have to do test flights throughout the competition in order to stay in it. Like it says there, the due dates have to be met to maintain a position in the final competition. So it does have deadlines throughout. So it is a very scheduled competition. And then on April 20th to 23rd, there's the final competition is hosted in Huntsville, Alabama. The past couple of years, the team hasn't actually gone to Alabama because of the pandemic. But you know, if we do wind up going, that is where the final competition is. You have the next slide. Okay, so the year's objective, there's a whole list of requirements, but this is sort of the backbone of it. Each year we have to design a different payload and then a launch vehicle or rocket around that. So this year, the objective is that the team shall design a payload capable of autonomously locating the launch vehicle upon landing by identifying the launch vehicle's grid position on an aerial image of the launch site without the use of a global positioning system, GPS. I mean, there's a lot to unpack there, which we're not going to get into tonight, but that is sort of the project that the team will be working around this year. You'll hear more from our payload design leads later on, and they'll tell you a little bit about the direction that we're going to be going with that. But if you're interested in, working in that sort of thing, then that is what we will be doing this year. Next slide. And then we also have built around that payload a preliminary rocket design. So just to give you a little bit of glimpse into what we've already done, this is a open rocket model, which is the software we use for our modeling and simulation, which you will learn about later on if you wind up joining the team, and if you don't already know. But this is just sort of the basic sort of what our rocket will possibly look like this year. So this is just sort of the very first thing, but it's a dual deploy rocket with a 4-inch fiberglass airframe. And the nose controller is doubling as the payload bay as of right now. And the motor is not confirmed yet, but you see we have a range there of sort of what we're going for in terms of the specifications. If none of this is making any sense, don't worry. This is still early on. And if you're new to the team, all of this will definitely be taught to you. But this is just sort of where NASA SL is currently. And if you have any more questions about it, you can always reach out to me or to any of the leads. And yeah, I think that's it for me. Oh no, it's not. Never mind. This is just the setup of NASA SL. So if you are interested in a specific portion, and you'll hear from all of these people tonight, but these are all of the NASA student launch leads. So you can see there's me, I'm the project manager, and then we have all of our sub-teams with the leads listed next to it. Dr. Lind is our faculty advisor, and we also have a mentor in the rocketry clubs around Florida. So any of these people you can reach out to if you're interested in any of these things, and you'll hear from them in a little bit here in the meeting anyway.
Hey guys, I'm Bilal Hassan. I'm the IREC project manager for this year. A little bit about me. I'm a 4th year aerospace engineering student, pursuing a 4.1 degree and also a minor in physics. You can see my email on there, but please hit me up on Slack. I'm not your professor. I started the team in modeling and simulation, and I stepped up to SL Flight Dynamics and then IREC Flight Dynamics my junior year. I look forward to meeting each of you and discussing your contributions to our rockets. Next slide. So a little bit about our IREC competition. So it's a rocketry competition held annually in Truth or Consequences, New Mexico. It's basically just a big desert. 150 teams from across the world participate, and we are competing in the 10,000 feet COTS or commercial off-the-shelf motor category. The mission is to launch an experimental CubeSat payload to 10,000 feet, and the design is completely open to us, so it encourages creativity. Next slide. So just real quick rundown of our IREC leads. We have Gavin on structures, Vishwak on avionics, Alex on recovery, Matthew on flight dynamics, Christian on ACS mechanical, Willer on ACS, Willer on ACS electronics, Tispan on ACS controls, Joshua on manufacturing, and Oz on propulsion. You get to meet each of these leads during the meeting, and our faculty advisor is Dr. Sean Mimi, and our mentor is Jimmy Yan as well. Next slide. So a little bit about that payload. So the Space Dynamics Laboratory runs a payload competition within IREC. The task is to deploy an experimental payload, or basically an experiment. Sort of.
Sorry about that. I pressed the button.
So the task is to run an experiment on a payload in a CubeSat. It's not going to space like that picture shows. It'll be going to 10,000 feet, but the experiment that you run is entirely up to you. So the technical requirements for it, the complete system, including if you're gonna, the payload and mechanical system, it will be 8.8 pounds. It must be in the CubeSat format, but that doesn't mean it has to be just one little block. It could be 3 blocks stacked together, or in any configuration of CubeSats. And it can be injected from the rocket, so you can have this thing fly if you wanted to. We're looking for ideas right now and any potential payload leads to build the system. So this is actually open to all majors, really. This is an experiment. So if you're a biologist, CS major, physicist, any major pretty much can run this. Maybe not art, but like practically everything. So if you're interested in designing a payload, a sign-up form will be sent on Slack, and you hit me up on Slack when you get the chance. Next slide.
Hi, my name is Joseph. I am the NASA SL Payloads Mechanical Lead. I'm currently a third year in the dual mechanical and aerospace major, and I was previously a member of Flight Dynamics and the payload sub-teams, but this year I'll be the lead of the payloads team. I am L1 certified and working toward my L2 certification.
Hey guys, I am Dylan Ogrodowski. I'm a third year electrical engineering major. I'm leading our SL Payload Electronics sub-team this year. This is my third year as a lead on the team. Next slide.
Hello everyone, my name is Abhishanka Saha. I'm actually dual majoring in computer science and economics, so nothing related to aerospace, but I love rockets. So I'm serving as the payloads leads for software. I was a member last year.
This year for the mechanical aspect of the payload, the mechanical sub-team for the payload is responsible for designing and manufacturing all of the structural components of the payload. And this year as a team, we'll be focusing on designing a 3D printed sled to hold the electronics. We also have to design the retention system to hold the payload inside of the rocket. And we are going to analyze the structural integrity of the designs. And to do this, we're going to be using SolidWorks, and you're also going to get some manufacturing experience on this team as well. Next.
All right, for the payload electronics this year, we'll be doing PCB design with Altium. So PCBs, schematics. We're going to be using XP radios, setting up transmitters, receivers. We'll be using microcontrollers and sensors. So if you've worked with Arduinos before, it's kind of like that. We're just going a step lower and putting them on our own PCBs, kind of integrating everything together. And then, of course, you'll get some manufacturing experience with soldering and putting together PCBs. Next slide, please.
Okay, yeah. So for this year's software, we'll basically be looking at the microcontroller and working extremely closely with the electronics team. The programming language which we can use varies according to the usage. So we'll be looking at that. Oftentimes we end up using multiple languages depending on the use, and then pretty much bringing them together. I think this is a very good area if you're interested in software development, because this also translates over when you're working into an industry. It's an extremely good opportunity to learn new libraries, new languages, and I think that that also reflects pretty positively.
Hello, can you guys hear me? Good. Okay. Perfect. My name is Alex. I'm the IREC Recovery and Certifications Lead this year. As you can see there's my email and my phone number. Whenever you guys need anything, just let me know. Just text me, shoot me a text. I'm always free to do anything or help out. I'm a third year aerospace and mechanical engineering dual major. Previously, I worked on SL Payloads my freshman spring semester, I believe, and this testing sub teams. My testing sub team was on the spring semester of my freshman year, and then the year after I worked on SDL payloads. None of them as leads, but within the sub team itself. I am currently level 1 and level 2 high-powered rocket certified. We will be going deeper into that, as Megan mentioned earlier in the meeting, later on. If any of you guys are interested in getting certified, I was a previous member of those two beautiful organizations, as you see there, and I just want to mention that my sub teams are open. New members, don't shy away from it, even though, you know, a lot of the information where you're being presented now is kind of intimidating, and even if you might not understand it, you know, I'm willing to teach everyone and guide everyone through. So feel free to reach out and join the sub teams.
Hey guys, my name is Willard Sanchez. I'm a fourth year aerospace engineering student working on my 4+1. I did summer research on wind gust modeling on MATLAB. I worked previously with SL and IREC flight dynamics, and I'll be working on the electronics for the active control system this semester.
What's up, y'all? I'm Christian Edgar. I'm the mechanical design lead for our active control system that Willard is also working on. I'm a fourth year dual degree in mechanical and aerospace engineering, first senior year. Let's go. It's also my first year as a lead and my first year on IREC. I did stuff with SL for a couple of years, flight dynamics and payload and whatnot. So got my email, got my number, hit me up.
Hi everyone, my name is Oz. There's my email and my phone number. I'm a third year chemical engineering student. This is my first time on the team. I am the IREC propulsion lead, and I'm hoping that this semester we can experiment with some propellants in a safe manner. And yeah, so if you have any questions about that or would like to join the team, just let me know.
Hi everyone, I'm Tizpan. I'm working on the control system for the ACS this year, and we'll talk more about that later, but I'm a third year and I'm dual majoring in mechanical and aerospace engineering. Freshman year, I did Avionics and Recovery, and sophomore year, I did flight dynamics and the ACS. So I'll have more experience with that. So the ACS this year, or the ACS is the active control system for a rocket. Originally, it was a air brake system with brakes that you can see on the top right, but it didn't turn out, and there are some issues with that we can discuss more if you join our sub team. But currently we're in the process of designing a different kind of ACS, a reaction control system that you can see on the bottom right. It's used on the space shuttle and other spacecraft to reorient themselves, and we're leaning towards using compressed gas shot out through nozzles. But we're also open to any other creative ideas, so if you're interested, join our sub-team channel in Slack.
Hey guys, my name is Fishback. I'm on the IREC Avionics team. I'm leading this team this fall. Those are my emails and phone numbers if you want to get in contact with me. This is also my last semester at the University of Florida. So I'm majoring in computer science, but also minoring in electrical engineering. I was on the ACS team last semester.
Hello, my name is Colin. I'm the NASA SDL Avionics and Recovery lead. I'm a third year aerospace engineering major. This is my second year as the SDL Avionics and Recovery lead, and I got my L1 certification at the end of last spring. I also do some undergrad research in orthopedics and biomechanics lab. So avionics recovery, we design, build, and then test alongside the testing team systems that use altimeters and the electronics to deploy parachutes. So we get to play with black powder. That's, it's one of the fun perks of our team. We also this year are planning on testing the altimeter's precision, and I would like to try to figure out a way to find the coefficient of drags for our parachutes, other than what the manufacturers give us.
Here is basically kind of similar to the IREC sub team as well. We basically work hand in hand with avionics, and if SL or IREC ever needs help, we work together with each other. We'll basically be focusing on IREC, a dual deployment system, and we're trying to be finicky and take it one step further, even though I don't know if it's going to happen or not. Like we're playing with CO2 canisters inside the airframe to eject. So we'll see how that goes. But if anyone's interested, definitely getting the rockets down to the ground safely is pretty hard, believe it or not. So we definitely need help if anyone wants to join.
So there's also the IREC Telemetry. So we're working on telemetry module for the actual rockets. So this team is great if you guys want to learn more about sensors, coding. If you guys are like computer science majors or electrical engineering majors, like this team would be perfect for you. Or if you're interested in that kind of stuff, this team would also be perfect for you. So we work heavily with Arduinos, various sensors, and also a lot of antenna design. So we also work on software as well. So we work on programs in Golang and Python. We store stuff in InfluxDB, and we also view that data using Grafana. And if you also want to learn about Dockerized containers, this would also be a great team for you.
Hey guys, my name is Brita Gibbons. I'm the SL testing lead this year. I'm a third-year aerospace engineering major, and I'm minoring in French. I was a testing sub-team member last year. I'm also a DML TA and a statics TA, so if you have any questions about those, just let me know. So testing is a really fun team because you get your hands on all parts of the rocket. Testing, of course, depends on the design. So it's a little bit different every year, but we'll definitely be working with ejection charges and whatnot. So it's really fun if you're not sure what you're interested in yet. I highly recommend coming to testing meetings.
Hey guys, my name is Matt Estenos and I'm the IREC Flight Dynamics lead. I'm a fourth-year dual major, mechanical and aerospace engineering. And my sophomore year, I did some work on the NASA SL Flight Dynamics subteam. Junior year, I returned as the lead for that subteam. And then this year, I have the lead position for the same subteam, but this time on the IREC team. So just another fun fact, this past summer, I had an internship at GE Aviation.
Hi, everyone. I hope you can hear me. My name is Krusha Patel. A little bit about me. I'm the SL Flight Dynamics lead this year, but I've been with Rocket Team in general for 2 years, working on both SL Flight Dynamics and IREC Flight Dynamics. So I'm a third-year mechanical and aerospace engineer, and I also am involved as the AIAA treasurer and the national liaison for our chapter, the special events chair for engineering ambassadors, and I've interned as a product design engineer at Cummins. A little bit more about me. I like crocheting, I like running, I like F1 race car driving, and then Dune, the movie is coming out, so I'm really excited about that. Another thing about me is I really like modeling orbits from Earth to Mars, so ask me about that if you're interested. And my goal for this semester as SL Flight Dynamics is to focus on teaching concepts used in simulations and developing individual projects catered to interest within our sub-team. So if you're in the sub-team, getting to know sort of the concepts of simulation and developing your own project to have something part of the team that you can say that you worked on and that you really contributed to. So don't hesitate to reach me. You can reach me through Slack or email. It's listed there. So a little bit more about flight dynamics. It's one of the first things that you do when you're building a rocket. It's very key to sort of understanding how all the other components will fit together, and it requires a lot of communication with all other sub-team members and other components. So the main thing that we use primarily is open rocket simulation in the beginning. And what open rocket is essentially, it's a result of a master's thesis, and it's used by amateur hobbyists, rocketeers, design organizations like us. And it's able to basically allow you to model rocket design. And you can model fin sizes, body tubes, nose cones and include different types of motors that you would like. And what this essentially allows you to do is to predict your altitude, velocity, acceleration, and drift. And the great thing about open rocket simulation is that just looking at it, it's very intuitive and it's beginner friendly, kind of like if any of you have heard of like, I think it's like Kepler or Kepler, I think the space program, that little app that allows you to like fly rockets. It's very beginner friendly. You look at it, but then at the same time, it can get as complex as you want it to. And you can really get into sort of the details and the nitty gritties of like numerical integration that they use. And as I mentioned, it's a result of a master's thesis. So like while the UI is very simple, the master's thesis goes into all sort of the dynamics of how the rocket goes about doing it. So we'll have a lot more information coming out on like how to actually use OpenRocket and, you know, be able to look into how to build your own rocket with it. So look out for that. But that for now is sort of the OpenRocket side of flight dynamics.
So the other major tool we use on the flight dynamics sub-team is MATLAB. So this is sort of different from OpenRocket. OpenRocket is sort of an established software that we use. Our MATLAB flight simulation is something we actually wrote as a team from the ground up. So it's different from the OpenRocket simulation in a couple different ways. This one we have a lot of freedom to change, modify, and improve. We can also tailor it specifically to the goals and parameters that we want to see and sort of, I guess, the inputs that we want to try out, things like that. So basically, when it comes to MATLAB simulation, we input things like the equations of motion of a rocket. We try to model that, different parameters to the design, and then the initial launch conditions for the vehicle. And then basically the MATLAB simulation takes it from there, solves some differential equations, and it predicts flight performance, certain parameters like the apogee, max velocity, things like that. So you can see on the right-hand side some of these pictures. These are the outputs that the simulation can generate. So there's some text outputs of just some parameters. You can see it generates a motor thrust curve, the flight profile, the altitude, and the vertical velocity. So the flight dynamics sub-team, a lot of our work can be on improving this simulation to make it better than OpenRocket in certain respects in terms of what we're doing and really tailor it to what we want to do. So there's a lot of freedom for creativity in working on this simulation. Then one final thing, just like Krusha mentioned with the OpenRocket, you don't need to come in being an expert on MATLAB. We'll teach you everything you need to know that goes for MATLAB and OpenRocket so that you can be successful on the team at any level of experience.
Hello, everyone. My name is Joshua Carson, and I'll be the IREC manufacturing lead this year. I'm a third-year aerospace engineering student from Jacksonville. I am also a design and manufacturing lab TA, and in my free time, which is 6 days a week, I am on the UF crew team as a varsity rower. Next slide. So this is a brand new branch of IREC. Oh, yes. So we have the opportunity to develop what it means to be a manufacturing sub-team. Overall, we're charged with collaborating with other IREC sub-teams to make sure designs follow basic design for manufacturing and design for assembly principles, while their components are successfully iterated, manufactured, and assembled for any applicable projects through to competition. This means that members of the manufacturing team will become comfortable with the nomenclature, design, and function of a number of rocket components as we serve the rest of the team. For our first projects, we'll be manufacturing modular fins, a propellant testing stand, and a body processing jig, which is the model you see in the top right of the slide. And of course, there's going to be more as the year progresses. These are just the initial ones that we're all thinking about. Overall, I'm looking for those of you who are interested in a predominantly hands-on role for building the rocket. And of course, no experience is required. DML experience is very helpful, but there will be plenty of opportunities to gain experience on the machines we have in our lab facilities, like the ones you see in this slide. And in addition to ones we may not use directly for manufacturing the rocket, but we can use for personal projects to gain more experience on those.
Hi, my name is Gabriella Pepburn, and I am the Educational Engagement Director. I am a second year aerospace and mechanical major, and I'm planning to minor in math. So if you would like to join this team, you will help lead outreach projects, manage events, write about our super important educational requirements in our report, and then present them to NASA. Super fun fact, I interned this summer at Embry-Riddle and designed and built splice hardware for the EagleCam payload, which super fun fact about EagleCam, it will be the first university payload on the moon, the first image capture of landing on the moon outside of the payload, and the first use of Wi-Fi to transmit data on the moon. So super fun to have been able to work on that. But email me if you want to talk about community involvement.
Hi, I'm Maggie Wheelatz. I'm the NASA SL Structures lead this year. You can contact me at that email or phone number. I'm a third year dual mechanical and aerospace major, and last year I was the educational engagement lead. This summer I got my L1 certification, and since summer I've been a design and manufacturing lab TA.
Hi, everyone. I'm Gavin. I'm a fourth year aerospace major pursuing the 4+1 path. I'm continuing my role from last year as the IREC structures lead. I'm L1 certified, and I specialize in solid mechanics. So I'm TAing for aerospace structures, and I also do research work in the micro air vehicles laboratory on campus. So the structures subteams are responsible for the main structural components of the rockets, like the fins and the body tubes, and a lot of the epoxy work and manufacturing and integration of common parts of the rocket.
So for NASA specifically, we do a lot of research in evaluating material properties of our different components, and we have a lot of fun manufacturing and assembling the rocket.
This year for IREC, we'll be doing our own carbon fiber layups of the rocket body tubes. That's been a year in the making for the process and development of it. And we'll also be designing a modular fin system so that everything isn't just glued in place, but we can actually make our own components working closely with the manufacturing teams to make good designs, but that also teaches a lot of valuable engineering skills that are used commonly in industry and are just good skills to have in general.
All right, so those are all of our leads between our NASA and NASA SL and IREC competitions. So the way that we're gonna hold these meetings in the future is that today was our introduction, our general body meeting. And then our future meetings are not necessarily going to be in this GBM style. We're going to try and do design meetings every Wednesday at the same time, and then they'll be in person. So the goal with that is instead of these GBMs where we just talk about what we've done, we want to try and include everybody more into these designs where we're going, okay, how can we apply all of these engineering skills that we've been learning in class? So these design meetings will serve as a way for you guys to come in person and talk with us as we go through iterations of design. So we're gonna say, why are we using this parachute? Why this specific structure? Why this or that? So that's what the goals of these future meetings will be. And then between these design meetings, we'll also have some other events. We're currently planning a technical showcase. So I know a lot of you guys have never seen a high-powered rocket. Maybe you saw it at tabling, but you don't know specifically what it is inside a rocket. Like what is each specific component? So the technical showcase that we're planning, it'll be a way for you to like see each of the components and talk to the leads as like they describe what it is that they do specifically. And then you can see on the rocket how they're responsible for that specific subsystem. Some other events that we have planned is we're going to do some industry insight. One of our sponsors is Aerojet Rocketdyne. We're going to have them come in for a talk. And we've also have some alumni. One of them is currently at Boeing, and we'll have them come talk with her team. Okay, so that's the end of this GBM. Feel free to join us on Slack, Facebook, Instagram. Slack, I heavily recommend you to join that. That is where we do all of our inter-team communication. That's where you're going to find out about launches, when each of our sub teams are meeting, and then when we're doing these meetings or when we're going to be meeting in person to talk. Additional announcements will be on Facebook and Instagram. Okay, so the link tree is an easier way to get to all of that. And then the Google form is from the very beginning. That's just the way for us to see like that you're interested in, make sure that you are up to date with all of our announcements. Okay. So I'm gonna stop sharing here. If there's any questions, feel free to drop them in chat. I will also give you guys the opportunity to drop into breakout rooms. So the breakout rooms, we're gonna split them between IREC and SL. You're gonna meet our project manager, Megan Wanak, and then Bilal Hassan. We're gonna give you the opportunity to talk to them and then ask any specific questions about each competition. So if you give me a second, I can set that up. And then if you have any questions, drop them in chat.
Do you mind if I add something really quick? Guys, don't be afraid to join the sub teams. It might look a lot complicated and you might be overwhelmed at the beginning, but we are all as leads willing to help you guys out and teach you what you guys need to know. We don't want you guys to look at the information and feel cluttered or feel lost within like any sub team. So we'll definitely try our best to teach you everything you
You cut out. Basically, what he's trying to
point
say
where you-
is join a lot of sub teams. You'll get a lot of experience, and it's not about like sticking to one sub team. At least for the first part, you can just join in on their meetings. It's not intimidating. It's just a couple of guys, girls, in a Zoom call. It's super fun, and yeah, go look around for work, and there's plenty of work to go around. So. I hope the meeting gave a good summary of all the sub teams. But if you have any questions, if you just go into the respective Slack channel of that lead, they'll have more about it. I know that Ozar wasn't here today for the propulsion section of IREC, but basically propulsion for IREC, you could talk to him more about it. But it's going to be developing solid propellant for sugar motors and ammonium perchlorate motors eventually when we get to it.
Have you, with the sugar motors, it's just nitrate and sugar, or do you add red iron oxide?
I'd imagine you'd add red iron oxide. I'm not super into the formulation. I'm not a chemistry guy, but considering that when you add iron oxide, you usually only add a small quantity, so we can even maybe
Like 1%.
characterize that. Yeah. The upper limit for it to be useful is like a curve. I forget what it's called. Yeah, it's basically once you get up to 1%, you're saturated. So we could try to do testing of that to see if it improves it. But yeah, 10% burn rate improvement. That's good. We could try it.
All right, so because I saw there was a propulsion slide. There's two sections, isn't there? All right.
Oh, did I miss this part of the oopsies? My bad.
Okay, so I opened up the
I'm not sure if I
breakout
lagged
rooms.
out.
I opened up the breakout rooms. You can feel free to join them. We'll also have a general discussion in here, so feel free to drop into the breakout rooms or you can stay here and chat with us.